Saxon Advanced Mathematics, lesson 31. This isn't a horribly long lesson, you guys, but it can be a little mind-blowing-y. So let's start out with an easy topic. Symmetry. Symmetry, when we're graphing, is the idea that sometimes our axis, y or x, can work almost like a mirror, right? So if we have a point that is 4 units to the right of the y-axis, and we have another point that is 4 units to the left, we can say that these 2 points are mirror images. If you think of this as a mirror and they're looking at each other in the mirror, kind of, they're symmetrical, right? They're points of symmetry across the y-axis, okay? We can also have points of symmetry that go across the x-axis. Let's go 2 up and 2 down. These 2 points are symmetrical across the x-axis, okay? So it can work from either axis, the x or the y. What if we add a circle to this? Circles are fun because they have many axes of symmetry. The circle is symmetrical across the x-axis, right? It matches top and bottom. It's symmetrical across the y-axis, side to side. It's symmetrical about the origin, right? Because every part of the circle is equidistant across the origin, right? And you can also consider it to be symmetrical across this line of y equals x. So it's a circle's a really fun shape because it is symmetrical in so many different ways. Symmetry is fairly easy and straightforward. We're not going to talk a lot more about it. Let's move on to our second topic, reflections. Let's consider this shape, okay? Here's our y-axis, here's our x-axis. We're not going to go down far, so I'm kind of leaving that out. Let's go out 1, 2, 3, 4, 5, 6. I don't want to fill all those in. 1, 2, 3, 4, 5, 6. And we've got a parabola that is this equation, y equals x squared plus 8x plus 16. And we have chosen some values and graphed that. And here's what we found. Now, I know this is sort of cheating because we haven't been doing a lot of graphing of parabolas yet. But just work with me. It looks kind of like this. Okay, the specifics aren't the important part. Okay. Now, let's say that we wanted to reflect this across the y-axis, okay? We want to create another graph just like this over here on the y-axis. The way that we do that is we take our same equation, but we change every x to be a minus x. Okay, compare the 2 equations. Where we had an x squared, we have a minus x quantity squared. This x becomes a minus x. We use parentheses to keep that minus sign in there close. And then the 16 stays the same. This graph is going to look exactly the same, pretend, except it is reflected across the y-axis. So what we did was we left y unchanged and we replaced every x with a minus x, and what that did was it reflected across the y-axis. Okay, this is super helpful information. We're going to need it for the homework, all right? Make sure you have that. Keep it handy. Now what we're going to do at the top of the next page, this was reflecting it across the y-axis, right? Now we're going to see, okay, what happens if you want to flip it top to bottom, right? Be symmetrical across the x. Let's go over and see. I'm going to draw you some more pictures. All right. We're going to use our same equation. The same starting equation, which was 1, 2, 3, 4, 5, 6. It was right here was our center of it, right? When we graph parabolas, we usually get this axis of symmetry on them. So this is our same starting equation. Starting parabola, and it looks the same. Y equals x squared plus 8x plus 16. In the book, John goes into a lot of detail about how he graphed, how he got from here to here. I'm not worried about that. I just want you to focus in on what that changes, how we get it to flip. All right? And then to get this one to flip, what we do is we leave, last time we left the y unchanged and we replaced every x with minus x. This time we leave the x unchanged, and we replace the y with minus y, and what that will do is reflect it. Last time was the y-axis. This will flip it on the x-axis. Okay, so these are the two tools that we use to change it. And we're going to practice doing that in a minute. What that does then is I now have a new equation that is minus y equals x squared plus 8x plus 16, right? I leave the x's unchanged and I replace the y with minus y. Then, because we always want the left side to be just a pure y, I'm going to multiply both sides by minus 1 to just move that minus sign over. Now I have positive y there, and this whole thing becomes minus quantity. Right? The minus sign will come up here, but I'm leaving all of this inside the parentheses. Look how different that is, right? Here, the minus signs attach specifically to the x values. Here, it's just on the outside. Another way that we can say that is when we, to reflect, okay, across the y-axis, we go from, messy, y equals the f of x to y equals the f of minus x. So what I'm saying is when we want to reflect across the y-axis, we put the minus sign with the x's. When we want to reflect across the x-axis, we'll go from y equals the f of x to y equals the minus f of x, okay? This is summarizing my two previous rules, and it helps you see that even though what we're saying sounds a lot alike, it's very different, right? Because this is the way we reflect across the y-axis. This is the way we reflect across the x-axis. To go across the y, the x gets the minus sign. To go across the x, the y gets the minus sign, which we then put in front, like we did there. All right? We're going to come back to this when we start to do the problems. Now, what about translations? That's the third topic we're going to discuss. And we're going to draw some more pictures and look at the rules. And then we're going to put it all together in a couple of problems. Let's talk about all right, let's start with a parabola that looks like this. Okay? And we're going to call him y equals x squared plus 2. He's like our base. Now we want to translate him or shift him down here, and we want him now to be at -8. Right? Before he was right here on the y-axis, and now we want him to be at -8. All right? Same height, but we want him to look like that. Pretend they're exactly the same. We take this equation and we change it because we're shifting him along the x-axis. We're going to change this to say y equals look what we did. We moved him -8 units, but we did +8 to the x value, okay? So this was to shift along the x-axis. We added the opposite value right up here tucked against the x. All right, and then if we want to shift again up here, pretend it's exactly the same, to +8, look what our equation's gonna look like. Y equals quantity x -8 squared plus 2. So we take the degree of the shift, the value of the shift, 8, we use the opposite sign and we tuck it right up next to the x, okay? So there's the base equation, and there's translating it to the left into the negative number. We move it with the opposite sign, and then here it is moving it in the positive direction. We use a negative sign. So these are translations. This is on the x-axis. So we're making the change to the x value. Let's contrast that with a translation on the y-axis, and that is going to look a little different. All right. Here's our first one. We're starting with that same base equation that we used up here. So the green one is the same. And we're calling this one y equals x squared plus 2, right? That looks the same. Now what we want to do is shift it up and down. So I'm going to use different colors because we're moving in different directions. Let's say we want to move it up 5. So 1, 2, 3, 4, 5. And let's say it's exactly the same shape. This, what we're going to do is say y. Again, we use the opposite sign, right? Here we used the negative to move in a positive direction, and we used the positive to move in a negative direction. We're doing the same thing, but this time, because we're moving it on the y-axis, we're making the adjustment to the y rather than the x. So it's y minus 5 equals x squared plus 2. But then we simplify that because we want to have the y by itself, so we add 5. So this becomes y equals x squared plus 7. Okay, so we clean that up and it looks a little different. But the rule is the same. You go to the letter that matches to the axis you're trying to shift along, and you use the opposite sign and the value. And then if we want to go down 5, 1, 2, 3, 4, 5, let's say it's right there. We want to do the same thing. We want to shift it down. We do the same thing. We do y plus 5, same measure, opposite sign, equals x squared plus 2. And then we rearrange, we'll be subtracting 5, so it will be y equals x squared minus 3. Okay, so here are our 3 variations here. Here's our original. Here's how we move it up. Sign's always negative, but with y, we clean it up and it looks different. And then here's how we shift it down with a positive value. Okay, there are the basics. We're not going to do a lot more on symmetry. We're going to talk mostly about the reflections and the translations and the problems. But we have 1, 2, 3 problems to do to put this into practice. Shall we begin? Example 31.1. The graph of the equation y equals square root of x is shown on the left below. Let me just copy that for you. It will look familiar. And you'll go, oh, whew, okay, that isn't too crazy. We've got this. Of course, this is x and this is y. I'll put those on. And we can write y equals square root of x. I'm not even going to put the numbers on there. It's not important for this one, okay? The graph on the right is the same graph reflected in the y-axis. And here's what we have. Pretend those are exactly the same. All right? Write the equation of the graph on the right. Okay, so what we have to do is figure out what's changed and what is the rule for making that change, okay? So is this a reflection or a translation? Well, it's starting from the same point. It's not shifting up or down or side to side. It's just reversed. So this tells us it's a reflection. And it's a reflection across the y-axis, right? So the way that we do that is, we can go back and look if we want, but we change, when we're flipping it across the y-axis, we change the x to a minus x. So we just copy this, y equals, and then we put the minus sign right up next to the x. And where was our rule for that? Here it is. You put the minus sign to reflect across the y-axis. You take the original function and you put the minus sign right up against the x. Ta-da! That's the right answer. Not terrible, right? If your brain's still attached at this point, because this is a lot going on, and we're going to get crazier too. Okay. The graph of y equals the square root of x is shown below, and it's the same as last time. It's like this and like this. Okay, this is y equals square root of x. And then it says, here's what's changed. Now we look at our after, right? This is before and after, before and after. Okay, so now we're down here at -3. My scale doesn't look great. Let me do one more so it looks better. -3, and then it goes like that. Huh, okay, that's considerably different, isn't it? So the first thing we have to do is figure out what have been the changes. First, we went from above the x-axis to below the x-axis. So that means we rotated it, or we reflected it. We reflected it down. To reflect it down from the x-axis, we change the y value. So it would be minus y equals the square root of x. That's how we would handle our reflection. Okay, that's the first step. But we've also translated it, haven't we? we've moved it 3 units on the x-axis to the negative, which means, I'm going to copy that and leave it the same. We also need to do square root of x plus 3, right? It's on the x-axis, so we're changing the x value. It's 3 units. Yes, it's always the opposite sign, so we're going to the negative, so it's positive. That's how we handle the translation. Okay, so we had to do 2 things. Now the last step is I'm going to multiply both sides by -1 to get rid of that minus sign in front of the y. I don't want that. So I get y equals minus x plus 3. This just comes and sits right out in front. And this is our final answer. And the last one is the hardest one, but I have a little hint to help you figure it out. Example 31.3. Graph the equation y equals 1 over x. That's really the hardest part. Then write the equation of the graph that has the same shape but is translated 3 units to the left and 4 sides down. Okay, blah, blah, blah. Okay, let's take a look at y equals x. That's like that, right? I can do that one in my head. I don't need a chart or anything. And then I remember that if we're going to do y equals 1 over x, that's where I have the asymptotes, right? And this is kind of a confusing thing, you guys. It's okay if this is making you a little crazy. Just remember, oh, I'm drawing it right on here. Okay? Just remember that this is the way the graph looks. I already drew it there. Right? We have these asymptotes that don't quite ever touch the line. Oh, this one is not as good. All right. All right, so that's what it looks like. That really doesn't even matter. What John wants us to do, though, is he wants us to shift it 3 units to the left. 1, 2, 3. And then 4 units down. And I'm going to do these in different colors just so we can handle the adjustments one step at a time. 4 units down, did I say? 1, 2, 3, 4. Okay? So it's going to go that direction, 3 units. Down 4 units. And let me just check and make sure I got the numbers right. Yes. Okay, so all we have to do is take this equation. We're not doing any reflection, so we don't have to worry about minus signs. We just need to make these adjustments. I can see this one's going to the negative and this one's going to the negative, which means in both cases they'll be plus, right? And so let's do this one first. The x value is what is changing here. So this is going to be x plus 3, right? We're adjusting our x value by 3. It's moving to the negative, so that means it's positive. Beautiful. Now I can make the rest of this equation the same because that's not changing. And then my y value is going in the negative direction, so that's going to be y plus 4. Makes sense? Because that's how the y value is changing, plus 4. And then the last thing, so this is correct. The last thing we want to do, though, is just isolate that y. So I will subtract the 4, and then we just have to be careful with our algebra. That goes away. We get y equals 1 over x plus 3 minus 4. Okay, that does not have a denominator. It's more or less floaty. And you know how I hate a floaty number, but that one's floaty. This is the correct answer. John did not ask us to graph it, but I just want to show you how you would graph it if you needed to. We got this, right? This is our original function. This is the reciprocal function, which you can just memorize it. It's kind of wacky. Now, if we're shifting this, we can measure, the way that it makes most sense to measure is to measure from the origin, because that's kind of the center of this whole picture. So just imagine doing it on a computer. Imagine clicking on the origin and dragging the whole graph over 3 and down 4. Now the origin is there, and that's what we've done here, right? There's the origin, now it's moved down here, and then you just redraw those vertical asymptotes into the quadrant, right? You're just taking, it's so much easier to think of doing it on a computer, right? You just click it, drag it, and the whole picture would shift to that framework. You were not asked to graph it, you were asked to write the equation. And that's what we did here. So, lesson 31 is done. If you feel like your brain has had a workout, it did. See you for lesson 32.